Hi there, welcome to the new session on computer and communication network. Today's session would be on network topologies. So before we actually get into the agenda of today's session, let's try and recap what we have done in our previous session. In the previous session, we saw fundamentals of data and signals. We saw what are analog signals and digital signals. I gave you an example of an analog clock and a digital clock. We saw what are data codes. We saw what are frequencies, bit rates, and we also saw what is attenuation, which is a general phenomena which happens in both analog and digital signals, and we saw what is signal to noise ratio. So that sets up the background for you to understand what are the different types of topologies. So in today's class, before we really understand the different topologies what we have in computer networks, we shall first see what a topology is, and then we shall focus on the various popular topologies like the bus topology, star topology, ring, mesh, and tree topologies. Okay. Now, what exactly is a topology? Now, as you can see here, a topology is nothing but arrangement of computers in a network. So, when computers are arranged in a certain fashion in a network, now we call them as topologies, and there are different types of topologies like bus, star, ring, mesh, tree, etc. Now, given you the snapshot of various topologies here, but we shall take one by one and look into it and see how exactly the computers are connected and what are the advantages and disadvantages of each of these topologies. So the first topology you are going to learn is called as an bus topology. So why it is called a bus topology? Because you have a central horizontal cable. The central cable which runs down from one end to another end is called as a bus, because this is the main carrier of signal, and this bus is connected to a number of workstations, and it could be connected to number of computer systems. Now here a computer system could be even a file server, and it could also be a printer. So the basic idea is to make this printer shareable. That means anybody here could be able to access the printer and should be able to print the documents. And know that the two ends of the bus topology, or the bus here, is actually terminated with a terminator. I shall explain you what is the exact use of a terminator in few minutes from now, but first let us try and understand how the data is transmitted in a bus topology. So let us say that this workstation A has to communicate with the printer, which means that the workstation A is sending some data to the printer. Now know that whenever A wants to send data to the printer, this data here, what I have shown here, would have the source address and the destination address. Now the source address of this data is A because the data is originating from A, and the destination address would be P1 because the recipient would be the P1. So what happens, the data travels from A to P1, but one point of importance here is the data travels from A to P1, but the data also travels to the file server, it also travels to B, it also travels to C, to D and E, which means that the data travels to all the systems along with P1, which means that whatever computer which receives this particular data examines whether that data belongs to him or not. For example, when this data packet arrives at this computer system B, B knows that this data doesn't belong to him, so he simply ignores it. But the P1 knows that this data packet belongs to him, so he accepts it, which means that the data is actually traveling to all the workstations here, and it will travel also to the end, which is nothing but the terminator. Now the terminator, what it will do is once it has reached here, the data has reached here, the terminator just cancels that particular data. This will basically avoid the data to bounce back into the bus. So this is how your bus topology basically works. Now you need to understand what are the advantages and disadvantages of this bus topology. Now, bus topology is very economical, which is less cost because you don't have much of the wiring here. It is easy to install. All you have to do is you have to pull a larger cable from one end to another end, and you have to install these workstations to the larger cable by means of a T connector. So it is easy to install. The main disadvantages is if the main cable is down, the entire network will be affected. Yeah, that is one thing which you have to understand. Suppose if this cable is not working, or if the terminator is not working, then there is no point of contact itself, which means that the entire network is down. This is one of the disadvantage. And the second disadvantage is it is not scalable. Now, what do you mean by scalability? You cannot simply add more number of systems to this particular topology. Adding more number of systems would make this topology less effective in terms of speed and efficiency. So you just cannot scale this topology, and security is minimal as every system receives the data sent from the source. Yes, this is very important because as I told you, when the system A is sending data to P1, that data of A is also reaching FS1, it is also reaching B, it is also reaching C, which means that there are every chances that B and C can be easily identify and they can read that particular data, though they don't do it, but there are chances that the data can be read by B and C. So we can say that security is very minimal in bus topology. So these are certain things which you need to know about bus topology. So bus topology is basically used in local area networks where minimal number of computers are interconnected with each other. Okay, now having understood what a bus topology is, we'll move on to the next topology, which is called as a star topology. Now, as you can see here in the star topology, you have a central device called as a hub. Now, from the hub, there are multiple connections which are going across, and each connection is actually connected to a workstation or a computer or a node, whatever you call it. Which means that every computer which is available on a star topology will have a connection to the hub. So hub is the central point of connection. It controls the entire transmission of data. Now in this case, what happens is if the connection between computer A to the hub is actually disconnected, still the entire network doesn't fail because only this connection will be hampered, but other computers will still be able to communicate with each other. So this kind of topology is called as a star topology. Now what are the advantages of star topology? It has got the centralized management of network using a hub. So hub is a central device which basically connects all the systems together. Now as I told you, if one of the computer fails, the rest of the network continues to work. Now this is because every computer will have a dedicated connection to the hub. So if one connection fails, it doesn't hamper the operations of the other computer systems. And what are the disadvantages? Now one basic disadvantage is if the hub fails, the entire network goes down. Quite understandable. Suppose if this hub is put off, or if the hub enters into some error, so what happens? The central management system itself fails, which means that the entire network comes into a standstill. And it is little more expensive when compared to bus topology because the hub is an expensive device, so you'll have to invest on the hub. That is why we say that the star topology is much more expensive than your bus topology. Okay, now having understood star and bus topologies, let's enter into another type of topology called the ring topology. Now you can see that in the ring topology, the computers are connected in the circular fashion. That means every computer would have certain neighbors. For example, the neighbor of this computer A would be B and F. Similarly, B would have neighbors like A and C. So two ends of the computers are connected to two different neighbors, and like this they basically form a ring. Now here also data is transferred from one system to another system. For example, if computer A wants to send the data to computer C, the data would have a source address and the destination address. Now the source address would be A because actually the computer data is originating from A, and the destination would be the address C. But one thing you have to understand here is A and C would not be the addresses. I am just giving you for you to understand it in a simple language, because the addresses would be not as simple as A and B. It would involve basically IP addresses. So from A, the data would transfer to C. So what happens? The data transfers from A to B. Now B would receive that particular data and identifies that the data doesn't belong to B. So B would have a repeater which will forward the data to C. So like this, every computer system would have repeaters which keeps on forwarding the data unless and until it receives its destination. So now the advantages of ring topology is flow of data is in a circular direction, which minimizes the chances of packet collision. So the data is traveling in a circular path. Now it has a better performance than bus topology even when nodes are increased, because of the transmission of data, and you have those repeaters which basically ensure that the data is traveled in the correct path. And troubleshooting in ring is much easier because cable faults can be easily located, because you can identify the cable faults very easily in a ring network. Now what are the disadvantages? A single break in the cable can cause disturbance in the entire network. For example, if the break in the cable is between B and C, suppose if this cable is broken down due to some reason, so the entire network would be hampered, and addition and removal of any node in the network is difficult and can cause an issue in the network activity. Suppose if you want to add a new system here, for example, I want to add a system called D1 between E and D, then what I need to do is I have to disconnect the cable between D and E, add a system, and then reconnect. So in that case, the network could be down for some time. So these are some of the advantages and disadvantages of your ring topology. Okay, now that you have understood the concept of a bus topology, a star topology, and a ring topology, now we shall see an entirely different topology called as an mesh topology. So as you can see here, the mesh topology, the connections are little messy. You can see more number of connections here. So here every computer is connected to every other computer on the network. For example, you can see here the workstation A is actually connected to workstation 1 using this cable. A is connected to 2 using this cable, and A is also connected to 3, and A is also connected to 4. That means every computer here is connected to every other computer using dedicated cables. So that makes the number of cabling more in case of a mesh topology. Now suppose if I want to find out how many number of cables are required, how many number of links are required, to be very precise, then all you have to do is you have to use the formula n into n minus 1 by 2, where n would be the number of nodes in this particular mesh topology. So in this case there are 5 nodes in this particular mesh topology. So I would require by applying this formula, so I would require around 10 links between 10 links in this entire mesh topology. Now what are the advantages of mesh topology? A failure of one device does not cause a break in the network or transmission of data. That is because every computer is connected to every other system on the network. So there is a dedicated connection. So if one system fails, it doesn't happen the entire network. Adding additional devices does not disrupt data transmission between other devices. That is also because of the dedicated connections. You don't have much disruption of data. But there are quite a few disadvantages in the mesh topology as well, and the number one disadvantage you can cite out as the cost of implementation. Since the number of cabling is more, as you can see, the number of links increases as the number of workstation increases. So the cost could be an predominant factor in case of an in case of a mesh topology, and that would be one of the major disadvantages of your mesh topology. And it is very hard to administer and manage because of numerous connections. See, a troubleshooting would be one of the major drawbacks of your mesh topology, which should be eliminated. Okay, now having understood what is a mesh topology, we shall see what a tree topology is. This tree topology is also called as an star bus topology. Now I can see here you have a bus topology, that is you have a bus here which is originating from one end to another end. You can also see the terminators between the two ends of the bus. And what is important here is the bus topology is connected to star topology. So you have a hub here. The hub is connected to a number of workstations. So you have one star topology on the top and two star topologies at the bottom. So in this case, what happens here is there are totally 3 star topologies which are actually connected to the main bus topology. So that is why it is a combination of star and bus topology. So we call it as a tree topology because it basically looks like a tree. Now what is important here is, suppose if the main bus fails, still your star topology will be functioning. This star topology would be able to communicate, and this star topology would be able to communicate on its own, but you will not be able to send and receive data from the other side of the bus, from one side of the bus to the other side of the bus, but you should still be able to communicate within that particular topology on one side of the bus. So this is one of the main advantage of your star bus topology. So thank you for watching this particular session. I shall see you in my next session. Till then, take care. Bye bye.